Hello everyone, welcome to my channel or welcome back to my channel. Means if you are a subscriber then welcome back. So now let us go ahead with this question. I shouldn't show you the solution first. Where is cursor? Okay, don't know. Today I'm thinking like I should teach in Hindi, but it will else. The thing is that whenever if we change the tone of language, then it also affects our interview as well. So it's better to practice in English only and understand the same. So apart from all these, let us start this question. First about the what this question is about, and then constraints. Because of those constraints only, we are able to get that at what things it could give TLE and how much time complexity should be there for this particular solution. So that's the thing. So now let us go ahead with this question. So as the name says, shortest path in a grid with obstacle elimination. So the thing is that we are required to figure out the shortest path and some obstacles would be required to be eliminated. Now here you are given an m cross n integer matrix grid, okay, where each cell is either 0, that is empty, 1, that is there is some obstacle, and you can move up, down, left or right from and to an empty cell in one step. So the thing is that we can go in all four directions by going ahead in one step. So means any four direction we can go and that will use our one step. So that's the thing here. And then return the minimum number of steps to walk from upper left means from the top side means if we are having okay I don't know how it looks. So the thing is that okay this is how it looks on your side, right? So the thing is uh means whatever is at the upper left, that is the thing. So from here, it want to reach at this particular point. So it require to reach like this or any other zigzag motion to reach at this point. Let me explain on the board only. That is much better. So the thing is that they require that whatever grid which is being given to us, right? So they want to reach at this point. Means inside this particular grid, not outside. Because surely we are required to go inside matrix only, and that path could be anything. Means and not in this exact, but in this manner, this, and then this. So like this also, or it could be even means this for the shortest in this case, or it could be like this also. So like this, the path could be anything. But the thing is that we are required to return the shortest path which would be possible. So let us go further. So that's the coordinate which they are giving to us, and we are required to eliminate at most key obstacle. So the thing is that in this particular matrix which is given to us, we are required to figure out with the shortest path. But there is one condition that we are required to um, eliminate at most k obstacles. So a k figure is this k. This particular grid is given to us and this k is given to us. So at most we are required to eliminate k obstacles. That would be the case. And if it is not possible to find such work, then return -1. And this could be in that condition when we are required to eliminate obstacle more than k, or yeah, this would be the case. When we are required to eliminate more than k elements, so in that particular condition, we won't be having any possible path. And that's the thing. At that moment only, we would be required to return -1. So now how this thing is like, we are given with a grid, right? And in this particular grid, let us say that this grid is something like this. And here, surely one won't be there. That's how we will be starting. That we will be checking from constraint. Might be there could be one. That constraint will let us know. Then we are having this one. Okay. Now we are required to go from shortest path by eliminating the at most k obstacle. Let us say k is equal to 1. So now what would be the shortest path we are required to reach at this particular point? So one shortest path could be like this. Means we can go like this, right? But at this particular thing, what we are required? We are required to eliminate this particular and this particular, right? And other shortest path could be something like this. Let me use an other color only. So other shortest path could be something like this. Means we are required to go here. Here you can see that 1, 2, 3, 4, 5, 6. 6 steps were required for this path. And for this path, let us say here if we go like this, right? So then 1, 2, 3, 4, 5, 6. Again 6 was required. And then here elimination was only not only one, it was two eliminations actually. So again this path is eliminated. So now let us go ahead with this path and then go ahead with this path, right? Here we can see that here we were required just this 1, 2, 3, 4, 5, 6. Here also the path count is 6, but here we eliminated just one obstacle only, right? And there is no other such path which is possible to reach this particular, right? So that's why here we will be returning 6 as our answer. And what I was trying to tell you was that you are required to eliminate at most k obstacles only. If at a particular path you are not able to, what we say, reach that particular point and reach that particular point by eliminating k obstacles, and there are basically more than k obstacle required to eliminate from that point, then surely we won't be choosing that path. But if less than k or equal to k obstacle are required to be removed, and that is the shortest possible path, because we clearly check that in a particular matrix how we are able to figure out with the shortest path. That we are only able to figure out when we do BFS in that particular matrix which is being given to us. If we do DFS, then it won't help us with the shortest path. So that's the thing here. We are here going ahead with the BFS solution that will let us know the shortest path. And regarding eliminating the obstacles, for that purpose, either we can eliminate those particulars in this only, in this matrix only, else we can take some other auxiliary space which will be replica of this particular only matrix, and from this particular and that particular auxiliary space we will be keeping a check that has till now in this particular path which we have chosen, are those obstacles which were eliminated equal to k, or are they less than k, or are they greater than k? So according to that only, we will be going ahead and checking that can we choose this path or not. So this is how we will be doing. So what exactly I'm saying is that first thing which we are required to do is we are required to do BFS. That is the short thing to figure out with the shortest path. Means how we do BFS over matrix. So that would be the basic question, means basic thing for this particular question. And now the second condition which is there is about eliminating k obstacles. So for that purpose, we will be having some auxiliary space, and because of that auxiliary space only, we will be able to figure out that this much obstacles have been removed in that particular path or not. If not, then we can move ahead. And if they have been removed and still we are required to remove some more obstacles, and then only we can reach our destination, then surely we will be not choosing that path. So these are the two things required in this particular question. Only modification from our standard BFS on a matrix is on the basis of this particular thing. So now comes the part, the time complexity and space complexity for the same. So time complexity for BFS on grid is basically M into N, right? And the space complexity, as I already told, that we will be taking auxiliary space for this particular thing. So that's why time complexity is order of N into M and space complexity is order of N into M, means both are same. We'll means while doing BFS, we'll check that do we require some more thing just because of this thing in our time complexity part, then we will update at that moment. Now let us go ahead with the coding part of the same. I guess I should code by now, means on the runtime, but it's okay. I'll explain comment by comment. So the thing is that we are starting, this is the starting point, that is the function which was being given to us. In a function, we are given with this particular grid which is there, right? And the k which is there, that is given to us. Now what we are doing is we are passing this grid and this k into some other function. But what I was thinking was that we can directly do everything in the previous function only. Why we require to pass there? Hmm, okay, 1 minute. I can write all that thing here also and can check that. If it works fine, then we will be going ahead. Okay, yeah, we can write everything in the same, because I feel like it's a good practice to make more modular code, but it's not that much good. Means just trying to make more and more modular code sometimes confuses as well. So now let us start with the same. Now the first thing is that what we are going to do here is we are taking one auxiliary space. In this we will be basically this is of this size, means size of this particular grid only, same as z means m cross n size. So that's why we are same vector of vector int visited and grid dot size, and then we are assigning the size of that particular column which is there, and then initializing with -1 means that whole grid would be initialized with -1 at the starting. It is same as that thing, only the way we keep DP array for our memorization purpose, right? So like that way only we are keeping here, but here we won't be memorizing because we are not doing memorization, we are doing BFS. So the thing is that it is just for keeping the track that if that particular value is there or not. So that's why we are it is starting initializing with -1. So this was the first thing which we are doing here. As per the algorithm which I had explained, means BFS and for elimination of the obstacle. So here for elimination of obstacle purpose only we are doing this thing. Now here this cube. So why we use cube? We use cube for the purpose of BFS only, right? And now comes the part that why we are using this vector of int. So here you can see that here the grid which is being given to us, right? So here each grid is having xy coordinates, right? So because of that xy coordinate only, we will be means the thing which we will be storing here is xy, right? Which will be directly as per that direction because we are required to check the minimum path which we can go ahead. So that's why we will be moving in all four direction as mentioned in the question. So for going in all four direction, we will be requiring the x and y path. x and y coordinate. So that's the thing. Now the third argument which we will be required is that current path length. That as we require with the shortest path, right? So surely we will be checking that till now at what path we have reached. Means what is the length of the path till now. So that's why we are also keeping this current path length. And then number of obstacles we can still remove. So because of this point only, we will be able to eliminate that particular path we want to go ahead or that particular path we don't want to go ahead. So this is the thing. And because of this only, while going ahead in this particular queue, we will be checking that can we move ahead in this particular path or not. Actually, this XY will also let us know that is that particular position at which we have reached. Is it valid position or not? Valid in the sense it shouldn't be it shouldn't be at these points means 0, 1, 2, right? So it shouldn't be at this particular point. Means here it will be -1, here also. Here it will be again -1 only. Means if we take, no, no, no. Means I just want to convey that it shouldn't be out of boundaries. So that is it, because this is not number line. So it shouldn't be just out of bound. It shouldn't be out of boundary. So that's why also we are having these coordinates to keep a check. But this out of boundary condition we will be required to check at later part. Because here just by giving that coordinate we are not able to check that it is out of boundary or not. For that we are required to explicitly make that decision. Now here that q dot push means basically we are pushing that into the queue means starting coordinates would be that 0 0 x is equal to 0 y is equal to not x's but the x coordinate and y coordinates means here this x and y both of them would be equal to 0 0. So that is the starting point. And here it is basically m-1 and n-1. So that's the thing. Because this whole matrix which is there, so this is 0 row, this is 1th row, this is 2nd row, this is 3rd row, and this is 0th column, 1st column, and 2nd column. So according to that only, everything is there, right? So that's why at the starting mode, we are having 0 coordinate for x, y, 0, and this path length which is there that is also 0, and k would be the obstacle number which is there. At the starting there is no obstacle, right? So that's why. One thing we forget to check about the constraint, that is m equal to grid size, and this m and n starting from 1 going till 40, and k can't be 0 at any moment. Means there would be possibility that we can remove at least one obstacle, and grid of ij is either 0 or 1, and grid of 0 equal to, yeah, this is the point. They have given that starting and ending will always be 0. So we don't need to keep a check. And that's why the solution also worked. Because there could have been a condition where we are basically required to keep a check that if our starting position itself is 1, then surely there's no path, right? So that's what I was saying. So here, while our queue is not empty, that simply means that still it is having some elements, because in our BFS, we first push the elements into a queue, means starting point, whichever is there, we push into the queue, and then we directly run a while loop for that particular, for checking that if our queue is not empty, then we will be proceeding ahead. And then how we proceed is, this is I'm just explaining out the BFS part. That first we will be popping out the current node which is being means let me use specific terms only. First we will be directly whatever there is at the front of that queue, that will be keeping in some variable, and then we will be directly popping whatever is there at the starting, so that we don't process that again. So that's the thing which we will be doing here. Now, next part is, means this is the only thing which we are doing here, because here you can see the type of our queue is basically vector of int. So that's why here we are having this vector of int t, and whatever is there at the front of our queue, that we will be storing in this particular vector of t. So that's the thing which we are doing here. Now comes the next part, that int x equal to t of 0, y equals to t of 1. So that is basically in this vector of t. At 0th position, our x coordinate is there, at y position, our y coordinate is there at first position, right? So that's why we are storing like this, and then we are popping from the queue. Now, first thing is that we will be checking that is it in bound of our matrix or not. If it is in bound of our matrix, then we will be going ahead. Else, if it is not valid, then we will be continuing. Continuing here simply means that we will be then checking for whatever is next element there in our queue, that we will be storing here and popping out. So that's the thing we will be doing. And this is not valid is something like this, that if our x is less than 0 or y is less than 0, or our x is basically greater than equal to grid dot size, or our y is basically greater than equal to grid of 0 dot size. And in that criteria, we will be returning false at that point. But in this, it will be returning true, right? And when it returns true, that simply means that it is not valid. And that's why we will be continuing. That is, again, we will be checking this condition, and then whatever is there, we will be popping out and processing the other node. And now that check has been done, now comes the part we are also required to check, means there might be a case that at any moment we are not able to figure out with the same. And then again we go ahead and check that if our next point which is there, it is valid or not. And again we are not able to figure out if valid. Then again we check. And like this only we are able to get to a final position. So that's why we are required to check here only that is our destination reached or not. So that's why here we are checking that if our x is equal to grid dot size minus 1, or y is equal to, means basically this position only, m minus 1 and n minus 1. If x and y are basically equal to this position, then we are required to return t of 2, that is the 0, 1, 2. The second index which was there, means the 2 index which was there, because we were storing x, y, path and obstacle, basically k. So we are returning this. That's the thing. And then here we are checking that if there is obstacle being found, and we will be checking this particular thing. If it is still greater than 0, then we are subtracting that now one obstacle has been removed from that path, else we will be continuing. Continuing is simply for this fact that we can't remove any obstacle till now. So that's why we are checking for the other node which we can go ahead with. Now comes the next part. Here, that visited thing which we had used. So because we are not whatever is there in the matrix, we are not changing anything from the input matrix. So that's why we are using auxiliary space. So here we are checking that if our visited of xy is not equals to -1, that simply refers to that it is having some other what we say, that other things stored there, and if it is greater than or equal to t of 3, that is the value which is being stored there is that value which was earlier stored. Means here you can see we are also storing the value in the same, right? So if this is the case, this simply means that we don't need to continue on this particular path, because either that obstacle at this particular path was already removed, and we had already visited this path before, and this path was already checked. So That's the reason we are not required to again visit this particular path. That simply means this path is already visited. So we won't be checking multiple time and the same, because this could easily lead us to what we say that uh, means infinite looping condition. So avoiding that, we are doing this. And here we are putting whatever k value is there, means now because k value would have been, you can say, decreased. Means earlier just k was stored in this particular T3, that was same. The original input k value is as it is, but the number of obstacles which we can remove till now, that have been decreased already. So that is what we are storing here. And this is the point when we are going to check in all four directions of our present coordinates. So we are basically adding up to our present coordinate a particular direction, either +1, -1, or 0. And same goes for this. So these are just storing those coordinates in our this particular queue. And then here we are storing the path, which is now again taken, means whatever was stored till now +1. That is what we are storing here. And here we are storing T of 3. That is till now whatever, what we can say, means whatever obstacles have been removed in that particular path. So that's what we are storing here. And this whole while loop is there. This whole thing, if it is, means if it hasn't returned from this particular while loop at this particular point, okay, then when it comes out at this point, then it returns -1. So that's the thing. We are keeping that -1 outside the same, else it would have been returned with this particular value only, means return path at this point only. This thing I was using for the direction, means this dx, which I was using here. This simply represent this 0 -1 will represent the upper direction. 1 0 will be representing my right mode direction. -1 0 will representing the left mode direction. And 0 1 would be representing my upper direction. And this first one would be representing the downward direction. So from this only I was using the same. And from this overall, we can directly see that BFS is just using that order of n into m space and order of n into m time complexity. So this was all for this particular question. If you still have any doubt, you can comment that down. And if you like the explanation, then please do like and subscribe to my channel and also share among your friends. And if you don't like the explanation, then also you can comment that down. I'll go ahead with the same. And I know that earlier I used to explain through that board also. Now I'm just explaining with this code. So yeah, this flow I know that next time I'll go ahead with again explaining on the board and then with the code. So yeah, this was all for this question. So yeah, thank you.